Unit. A unit is a standard quantity with which the unknown quantities are compared. A standard quantity is nothing but a quantity which has been predetermined by the scientists. That is, the amount or the magnitude of that quantity of a particular object or substance has been predetermined, has been calculated already by people or scientists. That is called a standard quantity. So, unit is a standard quantity with which we can compare the unknown quantities. Unit is also defined as a specific magnitude of a physical quantity that has been adopted by law or convention. Unit is specific magnitude of a physical quantity that has been formulated by scientists to use internationally, or the conventional units that we use locally. For example, in Tamil, in order to measure length in olden days, we used a word called mulam. Mulam, John, Gajam. These three words, these three units were used by our olden people, conventional people, to measure a length of any area. But if we use this word internationally, only Tamilians can understand what is the meaning of that word, because people in the world use different languages, so they don't know the meaning of the word Mulam, Gajam and John. So it will be a confusion for them. In order to avoid that, SI system has been introduced by the council. For example, feet is the unit for measuring length. That means 10 feet is equal to 10 times the definite predetermined length. This predetermined length is nothing but the standard quantity. Scientists have predetermined 1 feet. Okay, by using that predetermined 1 feet, that is the standard quantity, we can calculate how much is 10 feet. Okay, it will be the 10 times the predetermined feet. Okay, earlier, different unit systems were used by people from different countries. Earlier, different unit systems were used by people from different countries. This has been discussed in your earlier classes, 8th standard. So we go through this table column: CGS system, FPS system and MKS system. CGS system is nothing but length is measured in centimeter, mass in gram, time in second. FPS system, length is measured in foot, mass in pound, time in second. In MKS system, length is measured in meter. Earlier, different unit systems were used by people from different countries. This has been discussed in your 8th standard itself, so we can go through it. 3 systems, namely CGS system, FPS system and MKS system. In CGS system, the unit of length is centimeter, unit of mass is gram, unit of time is second. In FPS system, the unit of length is foot, the unit of mass is pound, and the unit of time is second. In MKS system, the unit of length is meter, The unit of mass is kilogram and the unit of time is second. So at the end of Second World War, all the countries in the world became friendly and had a good relationship and were trading with each other. Transportation and materials were shared with each other. In order to measure them correctly, there was a necessity for a system of unit worldwide. A system of unit that should be used worldwide so that all the people can understand what is that particular word means. Hence, SI system. SI system means International System of Units. SI means International System of Units was developed and recommended by General Conference on Weights. General Conference on Weights and Measurements at Paris in 1960 for international usage. Here in General Conference of Weights and Measures, certain rules and regulations were formulated to use the units internationally, that we will see in the following. Okay. SI system of units. SI system of units is the modernized and improved form of previous system of units. That is, previous systems nothing but these three systems. This SI system of units is accepted in almost all the countries. It is based on a certain set of fundamental units from which derived units were obtained by proper combination. So in this SI system of units, there are 7 fundamental units. They are called the base units. They are also known as the base units. These 7 fundamental units in the SI system are also known as the base units because these 7 fundamental units forms the basis for the derived units that we'll see in the following tabular column. So here is the tabular column for fundamental quantities and their units. There are 7 fundamental units, namely length, mass, time, temperature, electric current, luminous intensity, amount of substance. So the unit and symbol of all these 7 fundamental quantities are given here in this tabular column. We can see it one by one. Length, unit is meter, symbol is small m. Whenever you read a symbol, you have to specify whether it is a capital letter or a small letter, because both capital letters and small letters are used as a symbol for particular fundamental quantities. So whenever you read a symbol, you have to read it as whether it is a capital letter or a small letter. So first fundamental quantity is length, unit is meter, symbol is small m. Mass, unit is kilogram, symbol is small k, small g. Third is time, unit is second, symbol is small s. Temperature, Kelvin, capital K. For temperature, the unit is Kelvin, symbol is capital K. Electric current, ampere, symbol is capital A. Luminous intensity, candela, small c, small d. Amount of a substance, mole, M-O-L-E, mole. Unit is M-O-L-E, mole. And the symbol is M-O-L. All are small letters. Small m, small o, small l. With the help of these 7 fundamental quantities, the unit for other derived quantities are obtained and their units are given in the tabular column. There are about 10 derived quantities which are derived from these 7 fundamental quantities. We can see them one by one. Area expression is length into breadth. Unit is meter square, small m square. Volume, area into height, meter cube. Density, mass by volume, kilogram per meter cube. Whenever you see this expression, that is symbol, above that symbol if you see -3, you have to read it as per. Okay, per means -3. So kilogram per meter cube. Why we are writing like this? Because see here, the unit of mass is kilogram, the mass is divided by volume. This division is represented as -3 here. Once again I will repeat it. Here the expression for density is mass divided by volume. The symbol for mass is kg, or the unit for mass is kilogram. This mass is divided by volume. This division is expressed in terms of -3 here. Okay, minus. This division is expressed in minus here, minus symbol here. So whenever you read this expression, you have to read it as kilogram per meter cube. Per means divided. Okay. Next, velocity, displacement by time, meters per second. Momentum, mass into velocity, kilogram meters per second. Acceleration, velocity by time, meters per second square. Force, mass into acceleration, kilogram meters per second square. Or Newton, capital N means Newton. Pressure, force by area, Newton per meter square. Or capital P, small a, Pascal, Pascal. Pascal. Energy, work, the expression is force into distance, unit is Newton meter, or capital J, Joule, Joule. The last one, surface tension, the expression is force by length, its unit is Newton per meter. Otherwise you can read it as Newton meter. Next, fundamental quantities. Next, fundamental units. First one is length. Length is the extent of something between 2 points. Length is nothing but the extent between, this is one point and this is another point. The extent is the length. Okay. The SI unit of length is meter. 1 meter is the distance travelled by light through vacuum in 1 by 29 crore 97,092. 1 meter is the distance travelled by light through vacuum in 1 by 29 crore 97 lakhs 92,458 second. In order to measure very long distances, we use the following units. What is meant by very long distances? Long distances, we know that long distance is kilometer. And very large distances is the distance between the astronomical objects. What are astronomical objects? Astronomical objects are nothing but the objects that are present in the universe, outside the galaxy, outside our solar system. Those objects which are seen outside our solar system are known as astronomical objects. So there are 3 units that are used to measure very large distances. First one is astronomical unit, AU, light year, small l, small y. First one is astronomical unit, capital A, capital U, light year, small l, small y, parsec, small p, small c. Now what is astronomical unit? It is the mean distance of the sun. Astronomical unit, capital A, capital U. It is the mean distance of the center of the sun from the center of the earth. That is, this is the center of the sun. This is the first point, and this is the center of the earth. This is the second point. The mean distance between the center of the sun from the center of the earth is the astronomical unit. So one astronomical unit is equal to 1.496 into 10 to the power 11 meter. Sorry, 1.496 into 10 to the power 11 meter. Next is light year. It is the distance traveled by light in 1 year in vacuum and is equal to 9.46 into 10 to the power 15 meter. Parsec. Parsec is the unit of distance used to measure astronomical objects outside the solar system. So 1 parsec is equal to 1 parsec is equal to 3.26 light year. See, this picture clearly explains what is 1 AU and 1 parsec. With the help of this picture, we can understand easily. This is the sun and this is the earth. One astronomical unit. One astronomical unit is nothing but the mean distance of the center of the sun from the center of the earth. So this is 1 AU. See, this is the center and this is the center of the earth and this is the center of the sun. So the mean distance, average distance between the center of the sun from the center of the earth gives us 1 astronomical unit, capital A, capital U. And what is meant by 1 parsec? It is the distance between the objects which are outside the solar system. So this is the solar system. Here is another star, nearer star. It is outside our solar system. So the distance between the near star and our sun is called 1 parsec. So now we are going to learn about large units and smaller units. Larger unit is kilometer. See, micrometer, millimeter, centimeter, meter, and the largest unit is kilometer. So kilometer, small k, small m, in meter we will get 10 to the power 3 meter. Astronomical unit, capital A, capital U. Its value in meter is 1.496 into 10 to the power 11 meter. Light year, small l, small y, 9.46 into 10 to the power 15 meter. Parsec, small p, small c, 3.08 into 10 to the power 16 meter. Likewise, smaller units are also there. They are Fermi, small f, 10 to the power minus 15 meter. Angstrom, capital A, and we have to write a small 0 above capital A. Like you write a degree of an angle, no, you have to write it as like that. If you write simply A, it means the alphabet A. If you write a degree along with the A only, then it means angstrom. Okay, angstrom. That is 10 to the power minus 9, 10 to the power minus 10 meter. Nanometer, small n, small m, 10 to the power minus 9 meter. Micron, micrometer. Micron is always called as micrometer. Here this symbol should be read as mu, M-E-W, M-E-W. Micrometer, its value is 10 to the power minus 6 meter. Millimeter, small m, 10 to the power minus 3 meter. Centimeter, small c, small m, 10 to the power minus 2 meter. So here is one note given here, star asterisk mark. It means these two systems are not in the SI system, but they are still accepted. SI system means what? Scientific Council has framed some rules and regulations and formulated 7 fundamental quantities, but these two smaller units are not there in the SI system, but still we follow these units. Next smallest unit is atomic mass unit. Mass of a proton, neutron and electron can be determined using atomic mass unit. What are protons, neutrons and electrons? These are the subatomic particles. Protons, neutrons and electrons are the subatomic particles which are seen in an atom. So if we want to calculate a mass of an atom, this is the definition. Okay. So mass of a proton, neutron and electron can be determined using atomic mass unit. Its unit is AMU, small a, small m, small u symbol. Okay. So 1 AMU is equal to 1 by 12th of the mass of carbon 12 atom. We have to memorize this formula. So 1 AMU is equal to 1 by 12th of the mass of carbon 12 atom. More to know, mass of 1 milliliter of water is equal to 1 gram. Mass of 1 milliliter of water is 1 gram. Mass of 1 liter of water is 1 kilogram. Mass of the other liquids vary with their densities. Just you know, you understand. Okay. So unit prefixes power of 10, prefix and the symbol. How to read this? Okay. 10 to the power 15, beta, symbol is capital P. 10 to the power 12, terabyte. Okay, capital T. 10 to the power 9, giga, capital G. 10 to the power 6, mega, capital M. 10 to the power 3, kilo, small k. 10 to the power 2 or 10 square. Can read this is as 10 cube. 10 square, hecto, small h. 10 to the power 1, deca, d, small a. 10 to the power minus 1, deci, small d. 10 to the power minus 2, centi, small c. 10 to the power minus 3, milli, small m. 10 to the power 6, micro, mu. 10 to the power minus 9, nano, small n. 10 to the power 12, minus 12. 10 to the power minus 12, pico, small p. And last one is 10 to the power minus 15, femto, small f. So as I said earlier, in this chapter measurement in 9th standard, we are going to discuss about measuring instruments. There are 2 measuring instruments that we are going to discuss in this chapter. First one is vernier caliper, and this vernier caliper is used to measure length of an object or diameter of an object accurately up to a small quantity, that is millimeter, 0.1 millimeter accurately we are going to calculate. You can see the structure of this vernier caliper. Let me explain the structure. This vernier caliper has a main scale. So what is main scale? The graduations here from 0 to 6 written yes or no. This is the main scale. And a vernier scale. Vernier scale, this box. See this box. This is the vernier scale. In vernier scale, only 1 centimeter has been marked. but in the main scale around 16 or 20 centimeters will be marked. With the help of that we can identify the main scale and vernier scale. Also, this vernier scale has a particular special character, that is this vernier caliper. This vernier scale, that is this part of the vernier scale, will slide over the main scale. This instrument has been modeled such that this vernier scale slides over the main scale so that it can close and open. Next is it has two jaws, the lower jaw and the upper jaw. The lower two jaws are called outside jaws and the upper two jaws are called inside jaws, because the lower jaw helps us to measure the outer area of an object, whereas the inner jaws helps us to measure the inner area of an object. So consider a teacup or a pen cap. We can measure the length of a pen cap using a scale, but it won't be very accurate. We cannot measure the inner diameter of a pen cap accurately with the help of a scale, but with the help of this vernier caliper we can also measure the inner diameter of a pen cap very accurately. That is the main point. Okay, so this is the structure of the vernier caliper. Next, how we can use this vernier caliper. The first step in using the vernier caliper is to find its least count, range and 0. So what is meant by least count? Least count of vernier caliper, capital L, capital C, is equal to value of one main scale division by total number of vernier scale division. Here if you see in this picture, one main scale division is 0 to 1. 1 is the one main scale division, and divided by, that is divided by total number of vernier scale divisions. How much total number of divisions are there? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So totally there are 10 vernier divisions. So if we calculate, if we substitute in this formula, we get least count is equal to 1 millimeter of the main scale reading by 10, that is equal to 0.1 millimeter, or in centimeter we will get 0.01 centimeter. So with the help of this vernier caliper instrument we can accurately measure up to 0.1 millimeter or 0.01 centimeter. Next is we have to find errors in the instrument. What are errors? How are errors formed? See, these are instruments. By using these instruments continuously, these instruments will get wear and tear. Wear and tear. What are wear and tear? தேய்மானங்கள் in Tamil. இந்த கருவிகளை பயன்படுத்திக்கிட்டே இருக்கும்போது நம்ம என்ன செய்கிறோம், முன்னாடியும் பின்னாடியும் நகர்த்தி அளவெடுக்கிறோம். அப்படி அளவெடுக்கும்போது தேய்மானங்கள் ஏற்படும். அந்த தேய்மானத்தின் காரணமாக ஒரு சில எரர் உருவாகும். How we can see? See, this is a positive error. What is meant by positive error? If the 0 of the main scale and the 0 of the vernier scale coincide with each other. What is meant by coincide? If they are straight like this line, if this is the 0 of the main scale and this is the 0 of the vernier scale, and if these two lines are like are in the straight line like this. This is meant by coincide. COINSID, coincide. Okay. If these two zero coincide with each other, then it is called zero error, no error. Okay. If the zero of the vernier is towards the right hand side of the zero of the main scale, then it is called positive error. From the picture itself we can understand. Here the zero of the vernier scale is towards the right side of the zero of the main scale. If it is like this, then the error is called positive error, and here the zero of the vernier is towards the left of the zero of the main scale. மறுபடியும் தமிழில் சொல்கிறேன், வெர்னியர் ஸ்கேலோடைய ஜீரோ மெயின் ஸ்கேலோடைய ஜீரோவில் இருந்து ரைட் ஹேண்ட் சைடில் இருந்தது அப்படின்னு சொன்னால் பாசிட்டிவ் எரர். அடுத்த படத்தை பார்த்தீங்க அப்படின்னு சொன்னால் ஜீரோ ஆஃப் தி வெர்னியர் எங்கே இருக்குது, மெயின் ஸ்கேல் ஜீரோவோட லெஃப்ட் ஹேண்ட் சைடில் இருக்குது. அப்படி இருந்ததுன்னா நெகட்டிவ் எரர். சரியா? இந்த பிக்சர் பார்த்தீங்க அப்படின்னு சொன்னால் nowadays digital vernier caliper has been invented, and we don't need to calculate these errors. The small chip will calculate by itself these errors and all. So second instrument we are going to see is screw gauge. It is also like vernier caliper but small modifications. Here a U-shaped frame is there. In that U-shaped, the left hand side end is immovable, but the spindle end is movable. This spindle is attached to the main scale here. From here to here is the main scale. So this spindle is attached to the main scale, and this is pitch scale. This is the head scale and this is the pitch scale. This is called as the pitch scale. Okay. So this head scale will move front and back over the pitch scale. This head scale will move front and back over this pitch scale. There is a ratchet stop, a screw which will stop the further movement of the head scale. So if we screw tight this head scale altogether moves forward, and the spindle gets closer to this anvil. The object to be measured should be placed between these two ends. Okay. இதுக்கு நடுவில் தான் வந்து எந்த ஆப்ஜெக்டை மெஷர் பண்ணுறோமோ அந்த ஆப்ஜெக்டை வைக்கணும். மறுபடியும் சொல்கிறேன், ஸ்க்ரூ காஜில் பார்த்தீங்க அப்படின்னு சொன்னால் ஒரு யூ ஷேப்டு ஃப்ரேம் இருக்குது. அந்த யூ ஷேப்டு ஃப்ரேமோடைய லெஃப்ட் ஹேண்ட் சைடில் பார்த்தீங்க அப்படின்னு சொன்னால் நகராத ஒரு ஸ்டட்டு இருக்குது. இதை பார்த்தீங்கன்னா நகரக்கூடிய ஒரு ஸ்டட்டு. இந்த ஸ்டட்டுக்கு பேர் ஸ்பிண்டில். இந்த ஸ்பிண்டில் பார்த்தீங்க அப்படின்னு சொன்னால் மெயின் ஸ்கேலோட அட்டாச் ஆகிருக்குது. இந்த ஏரியாவிலேருந்து இந்த ஏரியா வரைக்கும் மெயின் ஸ்கேல். இதெல்லாம் பார்த்தீங்க அப்படின்னு சொன்னால் பிட்ச் ஸ்கேல், PITCH, பிட்ச் ஸ்கேல் அப்படின்னு சொல்கிறாங்க. இந்த பிட்ச் ஸ்கேல் மேலே இந்த மெயின் ஸ்கேல் ஹெட் ஸ்கேல் நகரும் வண்ணம் இருக்கும். இந்த ஸ்பிண்டில் இந்த ஹெட் ஸ்கேலோட அட்டாச் ஆகிறதுனால இந்த ஸ்பிண்டில் இந்த ஹெட் ஸ்கேல் வந்து முன்னாடி நகரும்போது இந்த ஸ்பிண்டில் என்ன செய்யும், ஹெட் ஸ்கேலோடு சேர்ந்து முன்னாடி நகர்ந்து இதோட போய் ஜாயின் ஆகும். இந்த ராட்சட் ஸ்டாப் எதுக்கு பயன்படுது அப்படின்னு சொன்னால், இந்த ராட்சட் ஸ்டாப் இந்த ஹெட் ஸ்கேலு மேலும் வெளியே வராமல் அப்படியே கலந்துட்டு வராமல் தடுப்பதற்கு இந்த ராட்சட் ஸ்டாப்பு கொடுத்துருக்காங்க. ஓகேவா? அப்போ இந்த மெயின் ஸ்கேலில் பார்த்தீங்க அப்படின்னா 100 மார்க்கிங்ஸ் இருக்கும். இந்த பிட்ச் ஸ்கேலில் ஒரு 15 மார்க்கிங்ஸ் இருக்கும். சரியா, அதுதான் நம்ம கணக்கு. So you can see the adjustment by pitch of the screw. The pitch of the screw is the distance moved by the tip of the screw for one complete rotation of the head. It is equal to 1 millimeter in typical screw gauges. இப்போ பார்த்தீங்க அப்படின்னு சொன்னால் இந்த ஹெட் ஸ்கேலை ஒரு திருகணும். If we screw once this area, இதுதான் வந்து டிப் ஆஃப் தி ஹெட் ஸ்கேலுன்றாங்க. இந்த டிப் ஆஃப் தி ஹெட் ஸ்கேலு ஒரு திருகணும் அப்படின்னா இந்த லைனில் இருந்து இந்த லைனுக்கு போகும். சரியா, அதுதான் 1 millimeter அப்படின்னு சொல்லி சொல்கிறாங்க. சரியா, அதுதான் வந்து pitch of the screw. So the pitch of the screw is equal to distance moved by the pitch by number of rotations by head scale. Next is least count of the screw gauge. The distance moved by the tip of the screw for a rotation of one division on the head scale is called the least count of the screw gauge. Least count of the screw gauge, capital L, capital C, is equal to value of one smallest pitch scale reading by total number of head scale reading. நான் இங்கே சொன்னேன் இந்த டோட்டல் நம்பர் ஆஃப் தி ஹெட் ஸ்கேல் ரீடிங் இஸ் 100 அப்படின்னு சொன்னேன். ஒரு திருகுனா அப்படின்னு சொன்னால் ஒரே ஒரு டிவிஷன் தான் மூவ் ஆகும் அப்படின்னு சொன்னேன். அதனால் ஸ்க்ரூ காஜோட லீஸ்ட் கவுண்ட் பார்த்தா அப்படின்னு சொன்னால் 1/100, that is equal to 0.01 millimeter. You should not forget this, okay? And also don't confuse with the least count of vernier caliper. So here also in this screw gauge also there is positive error and negative error. Nil error. If the 0 of the pitch scale and 0 of the main scale coincide with each other, then it is 0 error. Okay. Here positive error. இந்த பாசிட்டிவ் எரர் எப்போ கண்டுபிடிக்க முடியும் அப்படின்னு சொன்னால் ஃபுல்லாக க்ளோஸ் பண்ணி இந்த ஸ்பிண்டில் இதை வந்து டச் பண்ணிகிட்டு இருக்கும்போது தான் வந்து கண்டுபிடிக்க முடியும். சரியா, பார்த்தீங்க அப்படின்னு சொன்னால் நம்ம ஸ்க்ரூ பண்ணி டச் பண்ணும்போது இங்கே பார்த்தீங்கன்னா இதுதான் வந்து 0 பிட்ச் ஸ்கேலுடைய 0, இந்த ரெட் கலர் என்ன ப்ளூ கலர் லைனு, ஹெட் ஸ்கேலுடைய 0 இங்கே இருக்குது. அப்போ ஹெட் ஸ்கேலுடைய 0 பிட்ச் ஸ்கேல் 0 விட கீழ் நோக்கி இருந்ததுன்னா டவுனில் இருந்ததுன்னா then it is a positive error. Yeah. எவ்வளவு பாசிட்டிவ் எரர்னு எப்படி கால்குலேட் பண்ணுறது? இங்கே பார்த்தீங்க அப்படின்னு சொன்னால் 0 ஆஃப் தி பிட்ச் ஸ்கேலும் 5th டிவிஷன் ஆஃப் தி மெயின் ஸ்கேலும் கோயின்சைட் ஆகுது. அப்போ இத்தனை டிவிஷனு பாசிட்டிவ் எரர் அப்படின்னு அர்த்தம். நல்லா புரிஞ்சுக்கோங்க. பிட்ச் ஸ்கேல் ஹெட் ஸ்க்ரூ காஜோடைய ஹெட் ஸ்கேலை நல்லா ஸ்க்ரூ பண்ணி டைட் பண்ணிட்டோம் அப்படின்னு சொன்னால் இந்த ஸ்பிண்டில் எண்டு வந்து இந்த எண்டை டச் பண்ணும். புரிஞ்சுதா? அப்போ தான் வந்து நம்மளால் லீஸ்ட் கவுண்ட்டு அப்புறம் எரர்ஸ் எல்லாம் கால்குலேட் பண்ண முடியும். அப்படி பண்ணும்போது இது வந்து பிட்ச் ஸ்கேலோடைய 0, சரியா, 0 லைனு. இது வந்து ஹெட் ஸ்கேலோடைய 0. ஹெட் ஸ்கேலோடைய 0 பிட்ச் ஸ்கேலை விட பிட்ச் ஸ்கேல் 0லேருந்து கீழே இருந்தது அப்படின்னு சொன்னால் then it is a positive error. எவ்வளவு பாசிட்டிவ் எரர் இருக்குது, எவ்வளவு எரர் இருக்குது அப்படின்னு கண்டுபிடிக்கிறதுக்கு அப்படியே பார்த்துக்கிட்டே வரணும். எந்த டிவிஷன் ஹெட் ஸ்கேலுடைய டிவிஷன், எந்த ஹெட் ஸ்கேலுடைய டிவிஷன் பிட்ச் ஸ்கேலுடைய ஆக்சிஸ் லைனோட கோயின்சைட் ஆகிருக்குதோ அது அவ்வளவு பாசிட்டிவ் எரர் ஆகிருக்குது அப்படின்னு அர்த்தம். ஸோ இங்கே பார்த்தீங்கன்னு சொன்னால் இந்த ஃபார்முலாவில் சப்ஸ்டிடியூட் So 0 error is equal to positive 0 error is equal to plus 5 into 0.01 least count. So yeah, 5 into least count. 0 error is equal to positive sign n into LC. எத்தனை டிவிஷன் இருக்குதோ அத்தனை டிவிஷன் இன்ட்டு எல்சி. ஸோ இங்கே 5 டிவிஷன்ஸ் இருக்குது. அப்போ 5 சப்ஸ்டிடியூட் பண்ணி கால்குலேட் பண்ணோம் அப்படின்னு சொன்னால் we get 0.05 millimeter. So in this instrument there is a positive error. How much is that positive error? 0.05 millimeter. Since it is a positive error, we have to use minus sign. Positive error அப்படினாலே minus sign யூஸ் பண்ணணும். So the zero correction ல minus sign யூஸ் பண்ணணும். So the zero correction is minus 0.05 millimeter. Next, negative error. Negative error ல பார்த்தீங்கன்னா இது வந்து axis, pitch of the axis, இது வந்து 0 of the pitch scale. The axis line ல இருந்து 0 of the main scale, head scale வந்து மேலே இருக்குது. When you observe in this picture, the 0 of the head scale is above the axis of the axial line of the pitch scale. That means it is negative error. So how much division is coinciding with the, which division is coinciding with the axis of the pitch scale? The division 95 of the main scale, the division 95 of the head scale coincides with the axis. So calculating the negative error, 0 error is equal to minus of 100 minus n. N is nothing but the division with coincides with the axis line. Okay, so here in this picture 95th division coincides with the axis of the pitch scale. So when you substitute this value in the formula, we get 0 error is equal to minus of 100 minus 95 into LC, that is equal to minus 5 into 0.01, that is equal to minus 0.05 millimeter. Hence the zero correction of negative error, we use positive sign, plus symbol here, plus 0.05 millimeter. That's all in this chapter, students. We will see in a next new chapter in a while. Thank you.